To simplify a rational expression like 2x squared minus 2 divided by x squared plus 6x plus 5, we have to look for common factors between the numerator and the denominator. So it's a lot like saying, well, what if I wanted to simplify 2 over 4? Well, there's a common factor of 2 that's in both the numerator and the denominator, and it reduces to 1 over 2. The idea that I just used in that example is the same as what I'm going to do here. But first, I have to factor the denominator and I have to factor the numerator. So let's start there. For the numerator, x squared times 2 minus 2, I can factor 2 out from both terms, and I'm left with 2 times x squared minus 1. And the denominator, I'm going to try to break that into two pieces. See, I have an x and an x. I need two numbers that multiply to 5 and add to 6. Everything is positive, so it's got to be a plus 1 and a plus 5. So it's starting to look completely factored, except I haven't dealt with this x squared minus 1 yet. I think I could probably break that up into two pieces as well. So I'm going to take x squared minus 1 and try to factor that. Let's see. I have to have an x and an x. I need two numbers that multiply to negative 1 and add to 0. My choices would have to be plus 1 and minus 1, and nothing else would work. Okay, at this step, I've completely factored the numerator and the denominator. I just now have to find any common factors. I see there's an x plus 1 and an x plus 1, and I can cancel those, much like up here there was a common factor of 2 that I removed. Once they're canceled, I'm going to copy down the 2 and everything that did not cancel. And this is my final answer. I simplified this rational expression by removing all common factors between the numerator and the denominator. All right, let's try this idea, but in a more complicated example. So I still have a rational expression, just meaning I have a fraction, a ratio of polynomials. Let's see, in the numerator, I have 3x cubed minus 21x squared plus 36x. And in the denominator, I have 6x to the fourth minus 12x cubed minus 48x squared. I'm not sure where to start other than let's remove greatest common factors from the top and the bottom. In the numerator, I can factor out a 3x. And in the denominator, it looks like I can factor out a 6x squared. In the numerator, if I factor out 3x, I'm left with x squared minus 7x plus 12. In the denominator, if I factor out 6x squared, I'm left with x squared minus 2x minus 8. Okay, so I can keep going here. I can't start like canceling everything yet because this piece and this piece could probably still be factored a little bit further, so let's do that. I have 3x. I want to try to factor the numerator. I have my 6x squared. I'm guessing I can factor the denominator. Starting with the numerator, I have to have an x and an x. I need two numbers that multiply to a positive 12, yet add to a negative 7. That's got to be negative 3 and negative 4. The product is positive 12. The sum is negative 7, so that's good. For the denominator, okay, I have an x and an x. I need two numbers that multiply to negative 8, yet add to negative 2. Okay, so that would have to be a negative 4 and a positive 2. So everything is completely canceled, and what I'm noticing is I have a factor of x minus 4 that I can cancel. So let's see what we have left over. That's 3x times x minus 3 divided by 6x squared times x plus 2. And there's a little bit more that cancels as well. 3 goes into itself once and it goes into 6 twice. So this is really, I'll just put x times x minus 3 over x squared times x plus 2. But I still have this. I have an x to the first over an x squared. Maybe I'll even put that exponent here just to indicate there's 1x in the top, there's 2 in the bottom. I can cancel all of those with one of those left over, giving me my final answer of x minus 3 divided by, that's an x to the first times x plus 2. Everything is factored. There are no common factors, so this is my final answer.